Now let us just go immediately. So how Spark is able to achieve faster speeds? In-memory processing, Anil, I think I gave the hint about it, right? You will get more hints about it now. Okay, just let me flip from it. And so what I get from it, Spark related to batch and Storm related to live processing, live stream. Harsh, you have seen it, right? That when it comes to the Spark streaming also, you can actually replace Storm. There. Though Storm would be working in a completely different manner. Right. Now let me just quickly go. So guys, I have this my machine up, my virtual machine up, but since the display is something like, you know, not such a great one, what I have done is my virtual machine is there on my machine, and via putty I have connected to it. So let me you know, just clear it out. So here I have kind of, you know, already installed Spark. And I'm not going to tell you how to start Spark, how to do this. All of that is something which I'm not trying to cover right now. What I'm trying to cover here is kind of just to give you a feel that the same word count example, right? The same word count example which you saw, if I have to run in Spark, how exactly, you know, how good it would look like, or how fast you can perform it. Okay, so this is something which I'm planning to show you. Amitabh says, do we need to learn Hadoop if we know Spark? See, again, Amitabh, you can run Spark in various manners, right? If you're planning to integrate it with Hadoop, it's good if you can know Hadoop. Or otherwise, if you just know how to fetch the data from Hadoop and then submit it, that's enough. Amitabh? Right? Great. So, okay, there are some requests for increasing the font size. Just a second, guys. Oops. Please help me with it. I typically don't use it. Change settings. Change settings, and then I'll go to appearance, font. I would say, let's say 14 would be good. Apply. Looks good? Looks good to you guys? Great. Something to volume moves. Rajendra, I'm not really sure because, you know, guys, are you all able to hear me properly? I don't know. I have seen some 3, you know, points wherein people have said that they are not able to hear me. And there are almost, yeah, there are more than 250 people right now. Great. Great. Sure. Thank you. Thank you. So Rajendra, I think you need to just probably check it. Otherwise, you know, after this we are going to upload the recording also. We are going to upload the recording as well. So recording as well as this PPT. Probably this was a question from Lizzie or Subha Reddy or somewhere. I think Subha was there in yesterday's session also. Yesterday I took a session for Storm. So yes, you guys, you know, you will be getting it. So we'll be uploading it in Edureka blogs and all. Yes, definitely. This PPT and everything would be uploaded. Don't worry. Okay. So now let me just get started with it quickly. So now I have installed already Spark. So I'm going to cd Spark 1.0.1. This is the latest version. Though I think I would be covering 1.0.0 in the class. But anyway, now I would say when Spark shell. This is like your fastest way of invoking Spark. And you can see that your Spark thing comes up. It basically, if you're seeing this, and the next thing would be this. So this is the biggest proof that Scala is the main guy. So by default, your Scala, this thing will start. Though, if you want to test it out, let's say instead of Scala, you want to test it out in Python. There is something called PySpark. Okay, there's something called PySpark. PySpark would be, opening it. I will be covering some of those things in the class as well. How to invoke PySpark instead of a Spark shell, and what exactly is the, are the pre-steps which are required for you to come up to this stage, right? So anyway, for now, just assume that yes, somebody has installed Scala, Spark, and it is up and running for you. Now, how exactly to go about it? An interesting question wherein somebody has said that, is Spark only compatible in Linux-based systems? You can definitely install it in Windows as well, but again, recommendation would be Linux-based systems. So many, right? Okay, now, so we are into the REPL. Now, I've just kind of, created some small examples for you. So there is enough of Scala which is going on, but let me just kind of try to put it. So guys, this is val nums 1 to 10,000, and essentially I'm creating a range here. Okay, actually 1 to 100,000. 1 to 100,000, it's just a range. When I say val nums, it is, when I press enter, it just has created a collection. Okay, and fortunately it is not typing everything, right? So it just gives you 170 and dot, 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 dot. It just says that, hey guys, I've just created a range here. Okay. Now, once you create the range, this is where the magic of, this is where I would say the magic of Scala, or I would say Spark, comes into picture. Okay. Now, see this, val dist data is equal to sc.parallelize. So if you see, nums is something which I created and parallelize. Before this, see this, Spark context available as sc. Spark context is available as an sc variable here. When you will be writing your own programs, you will be creating a separate Spark context object. But here, when it comes to Scala, it comes inbuilt to you. Spark shell, it comes inbuilt to you. Okay, so this is where you have kind of, you're just saying, hey, I want to parallelize it. There are various other options also wherein you can actually specify what is the level of parallelization you want. Here I'm working on a simple machine, so I'm not even giving that option. But yes, you can say parallel of 3, parallel of 4, parallel of some another, kind of factor, whatever you want. So this time I've said sc.parallelize, parallelize nums. When I press enter, it just does nothing. It just does nothing. So this is where this is parallelize. Parallelize is all about that this particular data set is now parallelized to various threads or various machines which are there in your system. But for now, assume that they, when I talk about a single machine, it will all be about parallelizing it in the threads. Okay. Typically, this technique you will not be using in a distributed environment system. This is just to give you wherein I am injecting some data by myself. Typically, you would like to read the data from somewhere, right? So anyway, never mind that. We'll be covering that a bit later. But now, a strange thing has happened. When I said, well, nums 1 to 10, 100,000, it just created something. When I said parallelize, then it just said, it just gave you a bit description about it, that parallel collection RDD. RDD is a kind of heart of Spark. I'm not covering all of these things in detail, guys. I'm not covering all of these things in detail, but it is all about RDD stands for resilient distributed data sets. Okay, so what exactly is it? It's like this data set would be available to all of the machines. Anyway, how exactly and what would be the scenarios behind it, we'll cover later. But the point here is, the moment you said parallelize, it didn't do, because it follows something called lazy operations. Okay, so until and unless, so there are two kinds of things, transformations and actions. All of the transformations are lazy. They're kind of calculated, a graph is calculated, but they are not really acted upon until and unless you force an action. So whatever I did was a kind of a transformation. Now this is an action which I'm trying to do. So I can easily understand that this is kind of alien syntax, especially for those Java people, right? So what I'm trying to do is dist data wherein I parallelize it. I'm applying dot filter underscore. Underscore stands for, it's like wildcard star. Okay. Anything which is less than 25, collect. Okay. Now when I say collect, collect is like putting them together. Okay. In a single list all together. And when I press enter, see this. It was a simple program wherein I have created 100,000 numbers. Out of that, I just did a filter. If you are aware of pig, what was this operation? This operation was about do load and do a filter, right? So filter is using a closer. Yes, Harsh. It is definitely using a closer. So everything, whatever you are seeing under this is a Scala code, right? Right? So guys, isn't it interesting that if now I'm sure if you remember, if you have to write your own pig script and then try to run it, how much time would it take versus whatever time it took on the same machine, same configuration? You can try it on your own, right? So this is one thing. This is one thing. Try to run pig on local mode as well. Now, see this. Try second time. Even faster. Even faster. Right? Anyway, let me just not go much detail into this. Okay, there is a word count example. I try to keep two different flavors of it, but I would like to go for the third flavor. I mean, to the second flavor of it, just because of the time constraints as well. Let me just show you something here. Okay, so let me come out of it. Exit. Clear. This is ls. There is a file, typically readme.md. If I say key cat of readme, just a second guys, .md, and I say head, you'll see some of the, documentations all together, right? So the best place is, this is a pre-formatted kind of a text and something like that. Now this is the right time to perform a word count on this file itself. So what is it all about? So what I'm trying to say is, the first example you have seen wherein I have injected some data by myself. This is the example wherein you are seeing I am reading the data from a particular file. So I'm saying val IP underscore cached, okay, is equal to Spark context dot text file, and within the text file I'm just supplying the location of the file right now. So that's it. Okay, sorry, I'm sorry. I have to again invoke Spark shell. So I did it just to show you that, yes, in case if you are worried that what is happening behind the scenes, right? Come on, get fired up. Great. Now, so I've said this, and IP underscore cached does not have any meaning. It could be Vishal, it could be, Gopa or anybody for that matter, right? So it just created it and that's it. It is just keeping silent as of now. Okay, now see this. Val w is equal to input cache dot flat map. Flat map, you are aware, but when it comes to flat map, it's kind of list of maps or list of lists, just in case if people were not aware of it. So what I'm trying to do is I'm trying to take the line of it and then splitting it by space. Guys, you remember word count? I'm sure at least those guys who have attended my classes can easily correlate to it. Others also, but I typically spend a lot of time in that, right? So Satyam, yes, I can definitely be faster, but please understand that there are some more people, who might be new to this, right? So I have to give some time to them as well. Okay. Now, split by space, and then I'm applying a simple map side wherein I'm saying dot map word word, and word is herein I'm just saying word comma 1, right? So it might be looking like a spaghetti code to you, please do not worry about it right now. It's like I'm applying collections, and on the top of it I'm applying a lot of lambdas here. Okay, but it is all about just in case, just try to understand that this is a kind of your mapper phase, and then something interesting is happening. I'm saying dot cache, right? This is where I'm putting it in memory. This is where I'm putting it into the memory, and once I do this, then I'll say w dot reduce by key, star, basically underscore plus underscore. It's all about star, underscore stands for star, dot collect dot for each println. So a lot of things. Please do not worry about syntax. At the end of the day, I'm going to apply a mapper and a reducer, and then finally I'm going to just print it out. Okay. In the previous example, I was doing the exact same thing, but I was saving the data into a file. Guys, right? Guys, I hope you are able to see both of the things, right? And the difference was there I was not doing a caching. Here I am doing a caching. That's the only difference between these two codes. Are you all able to see that? Could you please confirm? At least not all. Some of you could confirm. Right? So that's the only difference, and due to which I have taken the third example. That the first one I was persisting it in the hard disk. In this case, I'm not persisting it. I'm persisting it in memory. Okay. So let me just quickly do this. I think I have read it. Very good. Now let me just fire up the second one and show you something. When I press enter, see this, nothing has happened. Though I have invoked a code here, I have invoked a code, but nothing has happened as of now. Okay. Now let me apply an action. See, if you remember collect or for each println, that is action. Yes, lazy transformations. Exactly, Amitabh. Okay. Now it's like the same thing of pig. Okay. Now reduce key dot collect dot for each println. Now see this. What will happen? Ran. Quick, fast. Word count. I'm not going to confirm word count and all here, but see this. Right, guys? Two lines of for word count program. See, 2 lines of word count program is fine. Run the very same program in Hadoop. Run the very same program in Hadoop, right? Guys, I hope you are able to recognize it. Can I get a confirmation? Have you seen how fast it ran versus whatever speed you were getting? No. Now the story is not over. The story is not over here. So if you are seeing it will take more than 30 seconds in Hadoop and it ran so fast here, the story starts now. See this. See this now. What will happen now? I am firing it again. I am firing it again and see what will happen. Even faster. Even faster. Even faster. Because I have cached it. First time it took a slightly longer time, right? For the first time. But it was still much faster than Hadoop. From second time onwards, it was even faster by its own standards. Right? Have you seen this? Right? Exactly, RAM is costlier than this, definitely, but yes, the prices are definitely, so there is always going to be a trade-off kind of a thing, but yes. Right? So how is the cache cleared? There are forceful ways of clearing the cache or re-evaluating an action. There are some of the things, Lakshman, I mean, which probably it's not really the right time to discuss all those things, but yes, there are ways to clear the cache. Either you reevaluate your action or you forcefully clear the cache. Right. So there might be a lot of new questions which might come up. Hey, you are putting the data in memory, fine. But at what stage should you put the data? That is also very important, right? how much data do you want to keep in memory, and what if your memory becomes full, right? So whether the spill should happen, spill should not happen, or should you never keep the data in memory, or whatever, right? So there might be various kind of things which will come, and of course Spark answers for it. It provides you various options the way you want to arrange your data. It gives you that full flexibility, right? Input split file is right now on the local file system. If I would have integrated it with Yarn, I could have put this file in SDFS and it would have fetched the files from there and run it. Isn't it interesting? At least to me it looks interesting. That's where in fact my journey to Spark started, probably I think not even a year, some months back.